Let's dive right into this explainer and investigate the dramatic history and the surprisingly uncertain future of our very own Milky Way galaxy. For a long time, we thought we had our galactic story pretty much figured out. But as our technology improves, the universe just keeps throwing us these massive curveballs.
We have literally been told for a century that our galactic home is doomed, that we are on this completely unavoidable crash course with our giant neighbor, Andromeda. But hold on to your hats, because brand new data is forcing us to question absolutely everything we thought we knew about our past, our local neighborhood, and our ultimate fate.
Here's the agenda for today's explainer. First, a violent galactic history. Second, the cosmic detectives. Third, uncovering ancient mergers. Fourth, the Andromeda collision mystery. Fifth, a 50-50 cosmic coin toss. And finally, number 6, our uncertain galactic fate.
Section 1 of Violent Galactic History.
To understand where we're going, we really have to look at where we came from. When we look up at the night sky, it seems like this peaceful, totally static expanse of stars, right? Well, the truth is way more violent. The Milky Way didn't just form in a quiet little bubble. It actually grew into the massive spiral galaxy we know today by acting as a sort of cosmic cannibal. It literally built its current disk of stars, gas, and dark matter by devouring its smaller neighbors over billions of years.
Section 2. The Cosmic Detectives. So, you might be wondering, if these cosmic collisions happened billions of years ago, how on earth do we actually know about them? Well, to piece together an ancient crime scene like this, we need some serious forensic tools. We combine deep space imaging from the Hubble Space Telescope, incredibly precise 3D star mapping from the ESA's Gaia mission, and get this, we even use the Chandra X-ray Observatory to measure our spiral arms by watching light echoes bounce off dust clouds from distant gamma ray bursts. It's like having a galactic time machine.
And the ultimate smoking gun? Globular clusters. These are immense collections of tens of thousands to millions of ancient stars. Think of them as perfectly preserved cosmic archaeological dig sites. By using Hubble to check their age and metal content, and Gaia to track their exact movements, astronomers can definitively point to distinct groups of stars and say, hey, those weren't even born in our galaxy. They are the actual leftover remnants of the dwarf galaxies our Milky Way swallowed whole.
Section 3. Uncovering ancient mergers.
Our cosmic detectives recently looked at 39 of these globular clusters hidden deep inside the inner 20,000 light-years of our galaxy, and they found a previously unknown ancient collision. We already knew about the Sagittarius merger, which started 6 billion years ago, and actually, fun fact, is still happening right now. We also knew about the Gaia Sausage-Enceladus merger 10 billion years ago, but this new one, the Low-Energy Kraken-Heracles, or LKH merger, it pushes our timeline back another 1.8 billion years. This massive crash happened a staggering 11.8 billion years ago, just a couple billion years after the Big Bang itself.
To wrap our heads around the sheer scale of the LKH event, we're talking about 500 million solar masses of stars crashing into the young Milky Way. Now, because our galaxy was basically just a baby back then, this incoming dwarf galaxy made up a massive fraction of our total size at the time. It fundamentally changed the entire evolutionary path of our galactic home.
Section 4. The Andromeda collision mystery.
Okay, so the Milky Way has a violent past, but this investigation is also about a massive, looming threat heading straight for us right now, the Andromeda galaxy. For over a century, since 1912, astronomers knew Andromeda was rushing toward us. By 2012, Hubble data seemed to lock it in, a 100% inevitable, catastrophic head-on collision in 4.5 billion years. It was accepted as absolute scientific fact. But here's the major plot twist. Thanks to the newest combined observations from Hubble and Gaia, that century-old consensus has just been totally thrown out the window.
It turns out, predicting a galactic crash isn't exactly simple math. When lead researcher Till Sawala and his team ran the numbers, they didn't just look at 2 galaxies in a vacuum. They threw in 22 different gravitational variables and ran 100,000 Monte Carlo computer simulations. Essentially, they tested every possible probability. And guess what? When you factor in all the tiny observational errors and look at the chaos of the whole system, that guaranteed smash-up just completely vanishes into uncertainty.
Section 5. A 50-50 cosmic coin toss. To really get why this isn't a sure thing anymore, we have to look at the other heavy hitters on the cosmic game board. It's a massive, unbelievably delicate tug of war. Andromeda's little satellite galaxy, M33, is tugging us closer. But our own satellite, the Large Magellanic Cloud, is actually yanking us off our orbital plane, literally pulling us out of harm's way.
Throw in the dynamical friction, which is basically gravitational drag caused by giant invisible dark matter halos, and things get very complicated very quickly.
Because of all these competing gravitational forces, the odds of the Milky Way and Andromeda actually merging in the next 10 billion years have plummeted to exactly 50%. It's literally a cosmic coin toss. In tons of their simulations, the two galaxies just slide right past each other, missing by millions of light years, because that gravitational drag never gets strong enough to pull them into a death spiral.
And hey, if you were still sweating over that original 4.5 billion year timeline that was all over the news a decade ago, you can officially relax. There's now only a tiny 2% chance of that early head-on crash happening. And honestly, considering our own sun is probably going to burn out in about 5 billion years anyway, an early fender bender with Andromeda is pretty much the absolute least of our worries.
Section 6. Our uncertain galactic fate.
So what does this all actually mean for us and our understanding of the universe? Well, while it's totally possible that tens of billions of years from now, our entire local group of galaxies might just mash together into one giant, boring elliptical galaxy, our immediate fate is wide open. The Milky Way and Andromeda might just do a gorgeous cosmic waltz right past each other, totally unscathed. The big takeaway here is that our galaxy is incredibly dynamic. And as we get better tools and better data, our understanding of our exact place in the universe has to evolve right along with it.
So it's a thrilling mystery, and the case remains wide open. We literally went from being 100% certain of our galactic doom to realizing the universe still has some major tricks up its sleeve. It kind of makes you look up at the night sky differently, doesn't it? Just wondering, what other incredible secrets